Hello, my name is Andrea Cuevas, and in this video we will be discussing the motor cortex. This video was created as part of an assignment for my Psychology 110 class. All of the material for this video came from Professor Yvette Gabriela's lecture titled Lecture 6, Motor Control. To begin, we're going to discuss the journey or pathway of movement, and that starts with the prefrontal cortex. This area of the brain, the green part in this image, is responsible for planning actions, making decisions, and predicting the outcomes of movement. To put it simply, it helps us decide what we want to do before we actually move. For example, deciding to pick up a glass of water before we move our arm. Next, the premotor cortex gets involved, which is this purple part in this image. It prepares and organizes our movements and combines information about our body's position and the environment. The premotor cortex helps us plan how to move. For example, now that we've decided that we want a glass of water, the premotor cortex plans how we're going to reach for a cup by adjusting our arm's direction and hand shape as we see where the cup is. Once the plan for movement is ready, the primary motor cortex takes over. So that would be the dark pink part right here. This area sends signals through the upper motor neurons to our muscles, actually making the movement happen. The primary motor cortex is like the final command center for voluntary movement. This is the point where we actually lift the glass to our mouths and drink water. The primary motor cortex is organized in a map-like way called somatotopic organization. This means different areas control different parts of the body. The motor homunculus is a visual representation of this map, as you can see right here. Some body parts, like our hands and face, take up more space on this map because they need more precise control. For example, fine finger movements like playing the piano require more cortex space than moving your back. So the motor homunculus shows us how different body parts are represented in the primary cortex, with areas like the hands and face taking up more space because they need more precise control. But how does this organization in the brain actually translate into movement of our muscles? That's where the upper motor neurons come in. The upper motor neurons start in the motor cortex and travel all the way down the spinal cord through the cortical spinal tract, as you can see in this image here. Most of these fibers cross over in the medulla, which is why the left side of the brain controls the right side of the body, and vice versa. For example, damage to the left motor cortex can cause weakness or paralysis in the right side of the body. Like I just mentioned, when the motor cortex or its pathways are damaged, it can lead to movement problems like paralysis or apraxia, which is difficulty in planning movements. However, the brain is also capable of plasticity, meaning it can sometimes reorganize and recover some functions after injury. For example, some stroke patients can regain movement with therapy. So, to sum it all up, voluntary movement starts with planning in the prefrontal cortex, preparation in the premotor cortex, and execution in the primary cortex. The motor cortex is organized as a map, and its neurons send signals through the cortical spinal tract to our muscles. Before I end this presentation, here's a fun fact. When you imagine performing a movement like playing a trumpet or pitching a baseball, your motor cortex becomes active even though you're not actually moving. That is all I have for this video. Thank you for watching.